All right, this lecture is on chapter 1 of Keith Stanovich's How to Think Straight About Psychology. The chapter is titled Psychology is Alive and Well and Doing Fine Among the Sciences. And in it, he provides an outline and like a mini history of how well psychology is doing. If we were to look at the statistics of student major selections and job statistics and growth percentages of a variety of occupations, we would also see psychology is doing extremely well. But as I mentioned in the previous lecture, I'm recognizing a lot of failures in applying scientific reasoning, so basic experimental reasoning, logical empiricism, in psychology and in the applied human services disciplines. So this applies a little bit to social work, education, guidance counseling, and so on. But Stanovich is very clear that in this book, he's talking about scientific reasoning in psychology, not all these other applied disciplines. So there are a couple of points that he makes, and the first, perhaps most important one, is what science is, or the approach of science, and some of the basic axioms of science. Before he does that, he talks about the public perception of psychology, and at the time, so this is going back into probably the 90s, the most recognizable name in psychology was Sigmund Freud. Perhaps that's still the case. Freud has a lot of social recognition. So if you were to talk about Burris Frederick Skinner, perhaps it wouldn't turn as many heads, but Freud, slips of the tongue, sexual repression, all of these concepts are popularly known if misunderstood. And so an important point about Freud is that his theory did not follow the scientific method. So when he developed psychoanalysis, so this was like 1899, 1900, 1901, he was a neurologist, and he recognized that talk therapy, or talking with his patients, curiously cured some of their neurological problems. And so he said, maybe this is like a form of surgery that I've learned how to do, and he developed psychoanalysis. The problem with psychoanalysis is that a lot of the hypotheses are untestable, so they're non-falsifiable. If I tell you that you as a human being will fall in love with the person who most represents your mother if you're a male, or your father if you're a female, or your father if you're a homosexual male, and so on. You get the idea. So the parent of the sex that you're most attracted to, it's non-falsifiable, because you could say, well, here's who I married, and they're not like my mom or dad at all. And all I have to say is, you're just ignoring the most essential characteristics that you find attractive to them. So there's always an explanation that can devalue any disconfirmations of my hypothesis. In other words, you can't provide any evidence that proves me wrong. Therefore, my hypothesis isn't right. It's non-falsifiable. Therefore, it has no strength at all in scientific reasoning. So in Stanovich's book and in the scientific practice of psychology, falsifiability is really important. We need to ask questions that evidence exists that could prove it false, and that there's a certain way to proceed in testing these claims, evaluating evidence, and taking as much into consideration as possible, but doing that in a way that's consistent. So it isn't anything goes. It's, okay, if I follow these steps in order and I practice critical thinking, then I will find the best solution, or I will find the best explanation for a question that I have, or a phenomenon that I'm interested in. And that's what the entire book is about. So what is psychology as a scientific discipline? Well, it is the data-based scientific study of behavior. So Stanovich calls it all human and non-human. I tend not to lump non-human behavior into the study of psychology. I prefer human-focused psychology, but we can understand that we can test like rats and dogs and pigeons and get a sense of behavioral trends, behavioral tendencies, things like that, in a way that's perhaps more ethical or safer, depending on which ethical board you're looking at. So the data-based scientific study of behavior, not the armchair speculation about human behavior, not the history of human behavior, not the philosophy and theory of human behavior. This is the data-based scientific study of human behavior. What does that mean? Well, there's three components that Stanovich covers here. One is that it uses systematic empiricism. Now, both of those words are very important to understanding the scientific study of human behavior. Empiricism means that it relies on the human senses. So there's 5 human senses. There's the sense of touch, and so it registers things that can be felt directly. Sight, it registers things that can be seen directly, heard directly, smelled and tasted directly, and then perhaps any instrument that can amplify those senses. So we might be able to see, or we might not be able to see cellular divisions and cellular mutations and activities with our bare eyes, but through microscopes, through EEG machines, fMRI machines, we can start to see things that are going on inside the body. But again, it's still visible. We're using tools to amplify what we can see, amplify what we can hear, what we can touch, what we can taste, and so on. But it is empirical. So the first, or the second part there is empirical. The first part, systematic. Systematic means that there is a procedure for collecting those empirical observations. So the procedure is highly rigorous. Rigor meaning stiff, unmoving, inflexible. It's always done the exact same way. In this office right now, it feels cold to me. I could guess it's probably 66, 67 degrees. I just heard a professor walk by and say, like, someone's got to turn on the heat. That is empirical. I'm relying on the sense I have on my skin of what the temperature is. But I could be more systematic about that. So there's a lot of variability on what feels hot and what feels cold. If I've just exercised, the cold might feel really good, and so I might think, oh, it's probably 75 degrees in here. But if I just came in from, outside and it was 30 degrees outside, then it might feel warm in here. So perception can be altered depending on context. So a more systematic way of relying on my sense of temperature might be to use a thermometer. Then I'm looking at something, so the mercury in a thermometer, or if I trust a digital thermometer, as long as we're rigorous in that approach. And so if I look at a thermometer, I can see where the mercury lines up. And if I give it to you, you can see where the mercury lines up. But both of us might reflect on, it feels 65, it feels 70. There's more variability there. It's less rigorous. So systematic empiricism isn't just empirical, but it follows a rigorous procedure for collecting those observations. So that's the first component of the database scientific study of behavior. The second that Stanovich mentions is public verifiability. I remember learning about this in college and thinking, okay, yeah, it's got to be publicly verifiable, just check that box. But that's an essential component of establishing a finding or establishing a theory if you get to that point. We'll talk about theories in a subsequent chapter. But public verifiability is akin to public scrutiny, public critique. And so I might have a study. I've conducted lots of studies. I've published a lot. But what I have to do is collect my data, design a study, collect my data, analyze that data, interpret its significance, write a manuscript or present it at a conference. And then I'm subjected to critique. And so people, other scholars themselves who are practiced in this scientific reasoning, they look over my manuscript and they ask of everything, was this done the best way? Was there a mistake they might have made that changes the meaning of what the results are? Did the researcher make an essential mistake, or was there some failure in the design process? Was the conclusion sound? Did it follow from the results? In other words, they go through it with a fine-tooth comb, and then they have a discussion and say, okay, is this something that we feel merits publication, or were there mistakes that need to be corrected? And that's the process. So by the time something reaches publication, That's why peer review is so important. That's a process I just described. By the time something reaches publication, not only was it designed by a scholar and conducted and analyzed by a scholar, but then it was subjected to a critique, and it had to pass through a bunch of hands of scholars and scientists before it ever reached publication. And that public verifiability, publication is the making public of something that was learned or something that was found, um, is essential to the process of the development of scientific inquiry and production. If a student writes a midterm paper or conducts a study and gives it to the professor, that's a little bit of the publication process or the public verifiability process. So um, ideally, and this doesn't happen often because students tend to have more essential failures that prohibit it from ever reaching this level, but you turn in your study and you get feedback from your professor, and that's at least um, with one other person, kind of a reciprocal verifiability practice. So the professor says, here are some things that you can change or improve, and so you make those corrections. If you gave it back to your professor and kept doing that until you reached like something that both of you could agree on, that would be peer review. It would be unblinded. There would be some problems with it, but at least that's a bit of the process. Usually students, when they get to the point where they're submitting something, they don't want to see it again. They don't care if they made a mistake, and so there's like a reluctance to kind of confront that public verifiability. Finally, scientific study of psychology requires the study of empirically solvable problems. So I mentioned earlier that Sigmund Freud asked questions that could not be empirically solvable. Namely, I gave the example of falling in love with the parent, the person who most represents the parent of the sex that you're attracted to. So that's his Electra complex, for example, or Oedipus complex. But that can't be disproven, therefore there's no evidence that you could collect to... You could collect evidence that would demonstrate it, or evidence that might seem not to demonstrate it, but at the end of the day, nothing could possibly make you reject that hypothesis because it's not testable, it's unfalsifiable. So in psychology, we might recognize the impact of socioeconomic status on mental health. And that's a really big but vague statement. In what ways does socioeconomic status impact mental health? Like, is it positive or is it negative? Okay, so maybe you can say it's negative, a negative impact, or a detrimental impact. How might we see that? How would we define socioeconomic status? What assumptions or hypotheses could we generate that we could then test? And what sort of evidence would we gather in order to test that hypothesis? Let's just pick one. And we might say people who grow up living beneath the poverty level. And so that's the lower half of socioeconomic status. That would be a lower, I guess lower class is what that would be called, lower socioeconomic class. We could say has a higher propensity for, or a higher likelihood for diagnosis of depression and anxiety. So those two things together. So we would compare the low socioeconomic status with middle to upper, and then actually test, like, so how many people have been diagnosed in each of those categories. But then just going through it, I'm recognizing, well, what sort of access do people in low socioeconomic status, what sort of access do they have to clinical mental health counselors? And so we would have to find a way to control that. So we'd have to find a scenario or a setting in which everyone has equal access, which we know isn't really true, because the more money you have, the more access you have, and the more time you have to utilize these resources. So just looking at that fairly broad and vague possible psychological relationship, we're recognizing that there are a lot of factors that we would have to control for, and it'd be very difficult to test that in a simple way, which is why when you get to research design, you have to be as specific as possible. Don't test a huge idea, test a very small one, and move from there. In a subsequent chapter, we'll talk a little bit more about how psychology operates on the frontiers of knowledge. So we take what's already been established and then look at what hasn't been established and how can we push those frontiers out a little bit further. All right, the next thing that this chapter covers is folk psychology or psychology in common sense. Um, I remember taking a lot of courses in college, psychology courses in college, and taking like the exams and just thinking that each question would simply tell me what I already knew, like that everything was a common sense. But the important reason to study psychology in a scientifically rigorous way is that a lot of times our common sense is incorrect. And so in this text, the one that came out in 2006 or 2005, I'm not sure what the publication date was. Let me check. I'm curious. Yeah, 2004, 2001 initially, and then again in 2004. It mentions the importance or the benefits of working a part-time job when in high school. As I worked since I was like 15 and a half. As soon as I could get a job, I was working. And I thought, yeah, it's teaching me responsibility. It's teaching me how to manage my funds. It's teaching me the value of hard work. And this is what I believe. These are values that were passed on to me and my family. But the actual evidence suggests that it's one of the worst things that you can do. People who work part-time in high school tend to work with people who are at semi-menial jobs. I mean, think of the kinds of jobs you can get when you're in high school. And so if you're working with adults, they probably don't care a whole lot about professionalism, responsibility. So you learn to maybe be jaded from a very early age rather than, so it's like the opposite of appreciating the value of hard work. You learn how to get away with things. You spend money on frivolous purchases because, and again, this is what the evidence shows, because you don't have to pay rent. You don't have to cover like basic food expenses. Your parents are often covering those. Perhaps you're helping out with rent in some cases. But still, the sort of context is that you would rather do nothing for a paycheck than value the kind of work that you're doing. So the evidence actually points against all of those values that people tend to have, all the beliefs that people tend to have about part-time jobs in high school. And we have to collect that data and test it to see and to evaluate it in a rigorous way to see if what we believe is actually borne out in the evidence or is actually true. I'll just do one more from the 11th edition of this book. You probably have heard that if you're taking a multiple choice exam and your first like gut instinct is to circle B, and then you go, oh, wait a minute, maybe it's not B. Nope, it's my first choice. My first choice is always the best choice. I better stick with it. And you move on to the next one. That belief that you shouldn't change an item is not true. Like there's no evidence for that. The evidence that people have are isolated anecdotal incidences. So they might change 8 answers in a test, and then when they find out that 3 of those were wrong or 2 of them are wrong, oh, that was one that I changed. I shouldn't have changed it. I always know you don't change an answer. The actual evidence shows that if you're uncertain about an answer you've just given, the best thing to do is to change your answer. You're more likely to get it wrong if you're unsure about it, what you've just selected, not the opposite. So again, these beliefs can be tested, and if they can't be tested, then they're in the category of empirically unsolvable problems. And until we develop a capability of testing it, it's going to have to remain there. They're going to have to remain there. But in those examples that I've just listed, it can be tested. And that's the way that psychological scientists think. Rather than asking these big, overarching, essentialist questions, and we'll get to that in a subsequent chapter, you learn to ask testable questions or develop testable hypotheses, ask solvable questions, and proceed in a way that's rigorous, that's systematic, and so on.